Hello everyone, and welcome for this third devlog on Astreterre. I'm OraNN, and the project of Astreterre is a game in development, a 2D tactical RPG inspired by Minecraft. Today we will see the progress on moving mobs in combat. Before I start talking about moving mobs, I completed the last devlog just before tweaking the display of entity order during combat. Now, the icons are no longer the same size. The active unit is bigger at the top. It is surrounded by white. The others are smaller. This also makes it possible to display one more entity, 7 instead of 6. We had to modify the node tree for this new interface and create new version of the textures of the smaller boxes. The changes to the script are minor. We just had to add a series of lines to manage the new box, the loop that allows you to fill in the boxes when there are less entities than boxes are being lengthened. Most of the work has been to improve the movement of mobs. To better understand the behavior of the algorithm, which was often bugged, Mimish had the idea to display the trajectory of mobs as one displays that of the player. So I took over parts of the GD script tutorials that I've been using from the start for the management of pathfinding. I recolored the texture of the arrow in red, then I created a tile map with the principle of auto-tile. A few lines of code are enough to display this arrow each time the creature moves. The arrow was particularly useful for seeing errors in the mob movement algorithm. The first difficulty was to manage the collisions. They worked great for the player, but not for the creatures. The collisions shown here in red are an additional layer, a specific tile map that is displayed over the scenario. The game board script manages the combat mode cells. It analyzes the collisions tile map and memorizes the forbidden cells. Then, at each start of an entity's turn, the game board script analyzes the position of the creature and the player to update the prohibited cells. It was at this point in the analysis of the prohibited cells that we had a problem that occupied us for several hours. To put it simply, the movement of the mobs is an articulation between several scripts. The one on the creature itself, which manages the choice of the square to be reached. The game board script, which analyzes the grid. The Pathfinder script, which calculates the path between two given points, and the timeline script, which manages the order of events within a game turn. It was the order of execution of these different scripts that was a problem. Some functions performed in the same frame as others instead of doing it one after the other. The creatures therefore did not know the correct positions of other entities when choosing a cell and a path. The problem was solved by improving in particular the script timeline so that it triggers the analysis of the grid before the script of the creature choose a destination and then calculate a path. The next problem was to find the right destination. The player's cells is prohibited. The entity cannot be on the same. So, a way had to be found to determine which cell adjacent to the player is closest to the creature. This diagram explains with two examples how we did it. We determined the coordinates of each cell around the player, then we created a path to each of them. Black cells are forbidden cells. The shortest path is the one the creature keeps in mind. For example, to go to the yellow cell, you need a path of 6 cells. For the orange cell, you only need 5 cells, so we only keep in memory this arrival cell and this path. The script itself that applied these ideas is a double loop that sweeps the cells around the player in order. We check each time that the cell is free, we calculate the path, we check if it's shorter or longer than the previous one, and we go to the next cell. When the loops are complete, we know which accessible cell around the player is closest to the creature. To choose the right path, there were initially two situations that seemed totally different to me. Either the creature was close enough to the player to join them, or the creature was too far away and couldn't reach the cell adjacent to the player. So I tried to manually calculate an arrival cell when the player was not in the creature's movement area, but the path could become too complex to avoid obstacles, and the creatures would get stuck easily without going around obstacles. In the end, the solution was much simpler. I added an action range variable, which is kind of a player detection area. Even though the creature can get to the player's side in a turn, it knows where he is. The algorithm calculates the entire path, then I shorten the path based on the creature's number of action points. As a reminder, a movement of one cell is equal to an action point. So it's 2 little lines of code that do that. And the script is the same whether the player is within range of the creature or not. In the end, we therefore have a much improved combat mode. Creatures can now move much better to follow the player and reach them by finding the nearest cell. Creatures take into account collisions and other entities on the ground. Thanks for watching this devlog. I hope he has you over. I am very happy to be able to explain the most recent advances to you. Do not hesitate to give your opinion or your suggestion in the comments. You can also subscribe to not miss the next devlogs. I broadcast at least one stream every week on Twitch to advance the development of Astreterre, and I upload it on YouTube. Thank you to everyone who helped this project, and in particular to Mimish. See you soon, bye bye!